Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 4 Notes 5. Today we're talking about the zero product property. So our learning target today is I can use and apply the zero product property. So now let's just talk about what the zero product property is. The zero product property says that if A times B is equal to 0, so some product of two things or more could be, but if A times B equals 0, then either A equals 0 or B equals 0. That's the zero product property. If my product is 0, something that I multiplied had to also be 0. So we can use that to help us solve these types of equations that we've been looking at when we factor them apart. So let's just take a look at number 1 and think about how we would solve this. So in number 1, I have this equation in factored form, x plus 6 times x minus 4, and it's equal to 0. Because it's equal to 0, I know that I can split these two factors apart. And that gives me x plus 6 equaling 0 and x minus 4 equaling 0. So it's kind of like having two different equations there. So I split each factor apart, set it equal to 0 because of the zero product property. And then I solve each one. Subtract 6, and I have x equals negative 6. Add 4, and I have x is equal to 4. So my two solutions are negative 6 and 4. Now, notice that there's a comma between them, but this isn't an ordered pair like we had in systems. This is two different x values that are both solutions. We just have two solutions to this equation. So I have x equals negative 6 and 4. In number 2, I have a factored form expression again, 2x plus 8 times the quantity 3x plus 2. The whole thing's equal to 0. So again, I can split those apart. 2x plus 8 equals 0 and 3x plus 2 equals 0. And then I solve each one of them separate. So 2x is equal to 0 minus 8, which is negative 8, and then divide by 2, and I get x is equal to negative 4. Over here, subtract the 2, so I have 3x is equal to 0 minus 2, which is negative 2, and then divide by 3, and I have x is equal to negative 2/3. So my two solutions are negative 4 and negative 2/3. Again, these are two values for x. This isn't an ordered pair. Notice I didn't put parentheses around it. These are two different values just for x. So let's take a look at number 3. In number 3, I have 2x minus 6 times x plus 4 is equal to 0. Split them apart. So 2x minus 6 equaling 0, add 6 to both sides, and I have 2x is equal to 6, and divide by 2, x equals 3. If I split this other one, x plus 4 equals 0, subtract your 4, and you've got x is equal to negative 4. So my two solutions are negative 4, 3. Now, technically speaking, we would list these things in numeric order, which is why I put the negative 4 first, but it doesn't really make a difference. You get the same answer either way. So let's split number 4. Again, I'm in factored form, so that's good, that's helpful. So I have x minus 4 is equal to 0, and x plus 2 is equal to 0. Add your 4, and I get x equals 4. Subtract your 2, and I get x equals negative 2. So my two solutions are negative 2 and 4. Now, when I take a look at number 5, I am left with a trinomial that is not factored. It's not factored here, so I need to go ahead and factor it like I was doing back in notes 3 and notes 4. So I'm going to do that. I'm going to set up my x. I'm going to look at my negative 20 for a product, and the middle term is 1. And then two things that multiply to negative 20 and add to 1 are 5 and negative 4. So I have y, that's a y, y squared plus 5y minus 4y minus 20, all equaling 0 still. Group those, and I pull out a y into y plus 5. Over here, I'm going to pull out a negative 4, giving me y plus 5, all equaling 0. So y minus 4, y minus 4 and y plus 5 are my two factors. Now, this is where we would stop on the earlier notes because we were just looking at expressions. But the very fact that we have this thing equaling 0 this right here tells us that we now need to split it and solve. So I have y minus 4 equaling 0, add the 4, and I get y equals 4. Then I have y plus 5 equaling 0, subtract the 5, and I get y equals negative 5. So my two solutions are y equals negative 5 and positive 4. Same thing in number 6. I'm going to start by factoring. So 6 times negative 6 gives me negative 36, and then middle term is positive 5. And when I find the two numbers for that, I'm looking at 9 and negative 4. 9 times negative 4 is negative 36, and 9 minus 4 is 5. So split those apart. 6p squared plus 9p minus 4p minus 6 is 0. And then I'm going to group those. So from this first group, I can take out a 3p, which leaves me with 2p plus 3. From the second group, I can take out a negative 2, which leaves me with positive 2p plus 3. So my two factors are 3p minus 2 and 2p plus 3. All still equaling 0. Again, on the past notes, we didn't have this equaling 0 part, so this would be our factored form. That's where we would have stopped. But now the fact that we have this equals 0, that tells me that I want to solve it. So then I need to split them apart and solve. So 3p minus 2 equaling 0, 2p plus 3 equaling 0. Over here, add your 2, and then divide by 3. Over here, subtract the 3. I get 2p equals negative 3. Divide by 2. P is equal to negative 3 halves. So then I list out my solutions. P is equal to negative 3 halves and 2/3. All right. Let's take a look at number 7. In number 7, I have p squared minus 2p minus 35. So I need to split apart my factors. I have a top product of negative 35, and then the middle term is negative 2, and that's going to give me a negative 7 and a positive 5. So some of you may start to recognize that when you are looking at things that have a 1 in front like we did in number 5, your factored form ends up being the 5 and the negative 4. Y minus 4, y plus 5. That's the same as the 5 and the negative 4. Now, that is only true when you have a 1 in front. But because I have a 1 in front here, I'm just going to go straight to that factored form of p minus 7 and p plus 5 equaling 0. But again, remember that that's only true when there's a 1 in front. So you'll see in number 8 how I'll have to go back to using the x. But for these purposes, I can skip the part of having to split the middle and group it because I have this 1 in front that tells me that these are my factors. So p minus 7, p plus 5 is equal to 0. Again, I'm still equal to 0. I still need to split it and solve. So p minus 7 equaling 0, p plus 5 equaling 0. Add the 7, I get p equals 7. Subtract the 5, and I get p equals negative 5. So my two solutions are p equals negative 5, comma 7. And now in number 8, like I was saying, this does not have a leading coefficient of 1. My leading coefficient here is 6. So I have to go back to grouping here. So 6 times negative 12. Well, actually, you know what? I recognize that there's a GCF in here. So why don't we take out that GCF of 2? I'm going to divide out a 2, and that leaves me with 2 times 3r squared minus 7r minus 6. That's going to make my life a little bit easier because instead of getting like a negative 72 up here, which would be ugly, I'm going to get just a negative 18, which is a lot easier. So I took out that GCF of 2. It's just hanging out front by itself. And then 3 times negative 6 gives me negative 18. The middle term is negative 7. That means I want a negative 9 and a positive 2. So remember that this 2 is going to come down to the end, and we'll talk about how that affects our solution. So I have 3r squared minus 9r plus 2r minus 6 equaling 0. I group those, pull out a 3r from the first group, which is going to give me r minus 3. From the second group, I can pull out a 2, which gives me r minus 3. So I have 3r plus 2 and r minus 3, all equaling 0, but don't forget about that GCF that was out front. Now, let's talk about that GCF for a second. My whole goal here is to solve, so I need to get rid of everything except for the r's. If I were going to get rid of this 2, that means I would divide by 2. But think about what happens when I take 0 divided by 2. Nothing. It's still 0. So I really don't need to worry about that GCF in terms of my solution because it's not making an impact. 0 divided by 2 is still 0. So I'm still just splitting the middle two parts and going from there. Now, if I would have had an r out here with it, I don't, but if I would have had an r out here with it, that would change my story because now this is a third factor that would need to be split equal to 0. But that's not what I have here, so we don't need to worry about that. So we'll get rid of that. Okay, so I have 3r plus 2 equaling 0, subtract the 2, and I have 3r equals negative 2, divide by 3, and r is equal to negative 2/3. Over here, r minus 3 is equal to 0, add the 3, and I get r is equal to 3. So my two solutions are r equals negative 2/3 and 3. All right, so let's flip over to the back and talk about the application piece of this portion. So I'm going to pick up with number 9. It says, a flare is launched from a life raft. The height h of the flare in feet above the sea is modeled by the formula h is equal to 100t minus 16t squared, where t is the time in seconds after the flare is launched. Let h equal 0 and solve 0 equals 100t minus 16t squared for t. How many seconds will it take for the flare to return to sea? So I want the flare to return to sea. That's what I'm looking for. That means my height is 0, which is why there's a 0 equal to that whole equation. So now I just need to look at that equation and figure out how do I best factor it. I have 0 equals 100t minus 16t squared. So look at the type of expression that you have that needs to be factored. In this case, there's only two terms and both of them have a t in them. So all I'm doing in this one is taking out a GCF. Okay, and again, that's because there's two terms, not three, and both have t's. So I have to just take out a GCF. That's all I can do. So I do that. When I take out a GCF, I recognize that I can take out a 4 and I can also take out a t. So that's what I'm going to do. Divide by 4t, divide by 4t, and take my GCF out. So I have 0 is equal to 4t, and then what's left over is 25 minus 4t. Okay, now I'm ready to split and solve. So now this is one of my factors because I'm looking at 4 with a t. So I have 4t equaling 0, and then I also have 25 minus 4t equaling 0. So those are the two factors that I'm looking at to solve, and I have to consider this one out front because it has a t with it. However, I'm going to divide by 4, and I'm going to get t is equal to 0. So we'll talk about what that means when we think of it in terms of time. Over here, let's subtract the 25. And I have negative 4t equals negative 25. And then divide by the negative 4. And I get t is equal to positive 6.25. So those are my two possible solutions. Now, it says how many seconds will it take for the flare to return to sea? So if I'm looking at t equaling 0 and t equaling 6.25, having a time of 0 doesn't make sense. Nothing has happened yet. No time has passed. So my only logical answer here is the 6.25, and this is measured in seconds. All right, let's take a look at number 10. So in number 10, it says the length of a rugby league field is 52 meters longer than its width. Write an expression for the area of the field. If the area of the field is 8,160 square meters, what are the dimensions of the field? Holy cow. Okay, so we're looking at a rugby field. This is a rectangle. we know that we've got a length, a width, and a width. And it says the length is, so length equals 52 meters longer than width. So width plus 52. That's going to be the same down here. Now I need to write an expression for the area of the field. Well, area of a rectangle is equal to length times width. But in this case, I know that my length is equal to W plus 52. So I'm going to plug that in there. So I have area equals the W plus 52 times another W. Distribute that in here, and I have area is equal to W squared plus 52W. Okay, so that's a good start. Now, the other thing that I'm told in this question is that the area of the field is 8,160. That can go in for area. So I have 8,160 equaling W squared plus 52W. Okay, now I got to solve this. So I need to subtract the 8,160 because I need it to equal 0. I have to make sure that this thing equals 0. So when I move the 8,160 over, then I have 0 equals W squared plus 52W minus 8,160. Now I need to factor, and holy cow, that's a really big number. So negative 8,160, positive 52. So I know that they're going to be kind of close to each other with a difference of 52. I need one to be negative and one to be positive because I have a negative product. And this is where you just get out your calculator and start trying stuff because these are really big numbers to try and figure out. So when I get out my calculator and start trying stuff, I end up with a negative 68 and a positive 120. So again, this is just going to be a trial and error for you on your calculator. So, but lucky for us, this leading coefficient is 1. So I don't actually have to split the middle and figure it out. I can just make those my factors. W minus 68 and W plus 120, which makes my life a lot easier. And then I split them to solve. So W minus 68 equals 0. W plus 120 equals 0. Add the 68. I have W equals 68. Then subtract the 120. I have W equals negative 120. So now these are our widths. And we need to ask ourselves which one makes sense for a width. Well, I can't have a negative length for something, a negative distance. That's not possible. So I know that this one cannot be my width, which means that 68 has to be my width. So if my width is 68 meters, that means my length is 68 plus 52, which is the positive 120 meters. So those are my two dimensions for the field. What are the dimensions of the field? There they are. Okay, let's go to number 11. In number 11, it says, at a pep rally, small footballs are launched by cheerleaders using a slingshot. How long is the football in the air before it touches the ground? So the hint here is that h is equal to 0 when the ball is on the ground. Your height is 0 when you're on the ground. And then it says, use the equation h equals negative 16t squared plus 20t plus 6. So I know that I'm looking for when this equation is on the ground. So I'm going to put 0 in for h, and I have negative 16t squared plus 20t plus 6. So I need to factor this, but one thing that I recognize before I even start factoring is the fact that there's a GCF here. I'm going to divide all of these things by 2, and when I do that, that's going to make my factoring a little bit easier. So I have 2, and then I have the negative 8t squared plus 10t plus 3 instead. Now I can figure out my factors. Negative 8 times 3 is negative 24. Middle term, positive 10. That means I'm looking for a 12 and negative 2. Remember that when we divide by that 2 that's out front, our 0 doesn't change. So I'm just going to get rid of that 2 and ignore it because it doesn't have a t with it, so I'm not worried. So now let's split the middle into the 12 and the negative 2. So negative 8t squared plus 12t minus 2t plus 3. And then group those. negative 8t squared plus 2t, 12t, and then negative 2t plus 3. From the first group, I can take out a negative 4t. So negative 4t, which leaves me with 2t plus 3. From the second group, I can take out a negative 1, which leaves me with 2, ooh, that should be a minus 3. 2t minus 3. Sorry about that. There we go. 12 divided by negative 4 gives me minus 3. Take out a negative 1 from the second group because I recognize that this negative 2 needed to be a positive. That's how I know I did something wrong over here, because then that 3 divided by negative 1 gives me a negative 3. There we go. So I have negative 4t minus 1 and 2t minus 3. So now I am going to go ahead and solve this. I have negative 4t minus 1, and over here I have 2t minus 3. So when I solve those two, I need to add 1, and I have 1 is equal to negative 4t, and then divide by negative 4, and I get negative 1/4 equals t. Over here, add the 3, I get 3 equals 2t, and then divide by 2, and I get 3/2 equals t. So now this is where we ask ourselves, which one makes sense? Do both make sense? Sometimes that's possible. Do neither make sense? Sometimes that happens too. And then you would just have no solution. In this case, we're talking about time in seconds. I cannot have a negative time. It's not possible. So this one over here is out. That means this is my solution. So I'm looking at t is equal to 1.5 seconds. All right, last question. In number 12, it says the feet of gymnasts making a vault leave the horse at a height of 8 feet with an initial upward velocity of 8 feet per second. Use the equation h equals negative 16t squared plus 8t plus 8 to find when the gymnast will reach the floor. This negative 16, by the way, has to do with gravity. That's why we've seen it in a lot of these questions. Because in number 9, 11, and 12, we all use that, because anything that leaves the earth and then is pulled back to ground has this gravitational pull of the negative 16t squared. So if you recognize that that was in a lot of questions, that's why. So we need to solve this. We want to know when it's going to reach the floor. Floor means h is equal to 0. So I take my 0 and I plug it in for h. And since it's equal to 0, I know that I'm going to solve it. I recognize here again that I've got a nice GCF that I can take out. All of these things are divisible by 8, so I'm going to take that out. I'm going to have an 8 out front, which leaves me with negative 2t squared plus t plus 1. So again, I can divide by that 8 to get rid of it because it's not changing my answer. So negative 2t squared plus t plus 1 is what I'm working with. And then I need to factor it. No t with the 8, that's why I'm allowed to do that, and that's all good. So when I factor it, I have negative 2 times 1, which is negative 2, middle sum of 1. So that means I'm looking at positive 2 and negative 1. There we go. Positive 2, negative 1. So split those apart. 0 is equal to negative 2t squared plus 2t minus 1t plus 1. So in the first one, negative 2t squared plus 2t, I'm going to take out a negative 2 and a t. So I have negative 2t, and then that leaves me with t plus minus 1. 2t divided by negative 2t gives me negative 1. So then from the second group, I didn't even put my parentheses in, there we go. From the second group, that means I would need to take out a negative 1 because that would leave me with positive t minus 1. So I have negative 2t minus 1 and t minus 1. So split those apart. That means I have negative 2t minus 1 equaling 0, add 1, negative 2t equals 1, divide by negative 2. Then I get t is equal to negative 1/2. I'm sure you are starting to recognize why that is a problem. Over here in the second one, t minus 1 equaling 0, add the 1, I have t is equal to 1. Again, we're talking about time, when, and we're looking at seconds. So if I'm looking at t equaling negative 1/2 and t equaling 1, this one's not possible because I can't have a negative time. That has to be my answer. So I'm looking at 1 second is how long it will take her to return to the floor. All right, that's going to take us to the end of our last notes video for Unit 4. Thanks for listening, and I will see you all later.